In this video, I'm going to go over some big ideas from the conservation of momentum activity that you did with your iPads, and then we'll do some practice problems. One of the key things that's going to be so important here is keeping track of all these different variables and different values. I've made a table here in the top right-hand corner, and you can see here we have 10 different variables and values we can have. And so we're going to need to be organized. We're going to need to be careful with these. We won't be using all of these in every problem, but just a warning, we may have 4 different velocities that we got to keep track of. Okay, so the big idea here is in all these collisions, we see that the initial total momentum of everything added up is equal to the final total momentum of everything added up. And we can just write that in variable form. P stands for momentum, so P total initial equals P total final. In this class, we're only going to deal with 2 objects, so I may have the momentum initial of object A plus the momentum initial of object B equals the sum of the final momentums of A and B. Now, the other way I can write this, and we're going to change this last equation a little bit, is I may not know the momentum of A, but I can calculate it. So I'm going to take the momentum of A times the velocity of A, the initial velocity. I shouldn't have put those parentheses there. So what this should be, hopefully this isn't too confusing, the momentum of A or the mass of A times the velocity of A initial plus the mass of B times the velocity of B initial. And this is equal to the momentum. So this right here is that. Those are the same thing. And we can do the same thing over here because there's not really a final mass or initial mass. So the parentheses should not be there. So we get this. Now this equation, velocity B final, will describe all our situations. On some of the situations, we may only give you a bunch of masses and velocities. Or sometimes we'll give you masses and velocities, and we'll just give you we'll give you a momentum value. And you need to realize that this whole thing combined, mass times velocity, is the momentum. Another thing that we need to realize, and this is a shortcut, you don't have to do it this way, is if we have 2 objects that stick together in a collision, they have the same final velocity. So if they stick together, that means they have the same final velocity. Or maybe they're stuck together at the beginning. And the way you can write that mathematically is instead of writing this as 2 different terms, let me show you up here. So let's duplicate this. So if we write this up here, and if they have the same final velocity, then the velocity variables are exactly the same. It's just V final and V final. Well, what do you notice here? This V final here and this V final here are both like terms. So we can factor it out. So we could write this as mass of A plus mass of B times V final. And that's just because of the way math works. For instance, if we wanted to distribute the V final through here, we'd multiply V final times A, times mass A, and V final times mass B, and we get these original terms. It's the same thing, but you can take a little shortcut if you'd like. Similar with a kind of a recoil problem. If they push off each other or they recoil, so if they're starting stuck together, if they start together, that means they have the same initial velocity. And again, I'm not going to show you on this one, but we could factor out that initial velocity variable since it's the same, and we could end up with this equation here in place of this entire side. So this right here that we wrote with the factored out VF would go in place of this entire right-hand side of the equation if it was a stick together. Or you can just use this big one for all of them. It does not matter. All right, let's look at this example here. It's all about keeping track of everything. So we're going to highlight, we're going to annotate, and we're going to do our B and A diagram, before and after diagrams. All right, so object A has an initial velocity of positive 4 meters per second, so it must be moving to the right, and a mass of 2 kilograms. So down here, what we're going to do is we're going to start with object A, and this is our before. We'll put the before on top and the after on bottom. So I drew object A, and I drew the mass in, 2 kilograms, and I showed it has a positive velocity moving to the right, and we don't know what the momentum is. However, you may just be able to calculate that easy, and you can add the momentum right here for the initial for object A. So go, and I want you to copy this part of the diagram, and when you're done with that, unpause the video. Now we go on to the next one, object B. Maybe I'll use a different color for highlighting here. We'll use green. Object B has an initial momentum of -3. So it's not telling us the mass, it's not telling us the velocity, it's telling us the momentum. The momentum is negative, so we know it's moving to the left. So for our before diagram, we're going to draw object B. I'm leaving the mass blank because we don't know what it is, and I'm leaving the velocity blank because we don't know what it is. But we know the initial momentum here is -3. So I'm going to fill that in for object B for the before. So you go ahead and do that as well. After the collision, A has now a final momentum of -1. So it's not telling us the mass, it's not telling us the velocity, it's telling us the momentum. I know that because it says the word final momentum here. Also, the units here are mass times velocity, kilograms times meters per second, so you know it's momentum. Earlier here, it said the velocity of A was +4, and it had just meters per second. So the units are going to be helpful to telling us what the information is. So we know the final momentum of A, so we go down here to the after diagram, and you're going to fill in A. We don't know, I guess we still know A's mass. We could keep that on there if we wanted. That'd be a good idea. There's A's mass. We don't know A's velocity, but we do know A's final momentum. And then the last thing that we're being asked to find is how much momentum does B have after the collision? And so in our before and after diagram, I don't know B's velocity after the collision. I don't know B's mass, but I want to know B's momentum. Okay. So if you do this diagram consistently, you'll be able to see very easily the velocity of the object, the mass of the object, the initial momentum of the object for before and after for each. Okay. Part A, write out the conservation of momentum equation with just variables. That just looks like this. All it says is the momentum before of both objects added together, the total momentum, is equal to the momentum after. Now we're going to plug in any of the given momenta. So did they give us a momentum of anything? Yeah, they did. I can look on my diagram. I don't have the initial momentum of A, so I'm just going to leave that blank. I do have the initial momentum of B, so I'm going to take that and plug it in for B initial there. I have the final momentum of A, -1 kilogram meters per second, so that's going to go there. And I'm looking for that one, so that's going to go there. So now I have an equation with 2 unknowns. I need something more. This momentum of A, I can calculate it by doing the mass of A times the velocity of A. And I look over here to my before and after diagram, and I see, oh, I have the mass of A, and I have the velocity of A. This diagram takes some time to draw, but it's quicker than rereading the entire problem every single time. Okay? So I'm going to substitute in the mass of A and the velocity of A. Got to make sure I keep that positive sign in there, because if it's negative, it's going to change everything. And then I can solve for the final momentum. Okay? Now, before going on, what I'd like you to do is go on to the next problem. And I want you to do as much of it as you can. Do a very careful diagram. And then when you get to the end or when you get stuck, come back to this video, and I'm going to continue on with problem number 2. So pause this video now and go do problem number 2. All right, hopefully you got pretty far on problem number 2. Here is my before and after diagram. I know the momentum initial of object B, and I know the mass and velocity initial of object A. And I switch these on either side because of the directions of those velocities. If they're going to run into each other and A is moving left and B is moving right because it has positive momentum, B has to be on the left so they hit each other. If, let's say, you labeled this one B and labeled this one A, you just got to be careful that you don't mix up any of the values. As long as all the values on the left-hand side are correct and all the values on the right-hand side are correct, if you mislabel the objects, that's okay. Okay, the conservational momentum equation is just the same. This time here we realized, hey, we're not going to have the initial momentum of A. Wait, hold on a second. We have, B. I've switched these with my left and right. I was confusing myself there. We don't have the initial momentum of A over here, so I wrote mass times velocity A. When I substitute everything, I'm just going from my diagram and copying it into my equation, just like we've done all year long. So I'm going to copy my mass of A and my initial velocity of A from right here. I have my momentum of B, initial, right here. I have my momentum of A final right here. And I need to find my momentum of B. That's an unknown. Now notice here, this is not correct. This is not the final answer, because I need to solve for B's final velocity. So when we did this key the first time, we solved for the final momentum, but we want the velocity. So you have two options here. You can solve for momentum and then rewrite another equation. Or, I'm going to change this here. What I'm going to do here is I'm going to say, oh, this is going to be the mass of B times actually here, I'll do it up here. The mass of B times the final velocity of B. And my next step when I'm plugging in numbers, I know my mass of B is 2.5 kilograms. So 2.5 kilograms times my final velocity of B. And now at this point, I know all the values that I need in order to solve this. So on the left-hand side, I'm going to have, whoops, I'm erasing stuff. There we go. Let's get a calculator going here. I'm going to have negative 27, and then equals minus 20 plus 2.5 times VB final. You cannot combine these two, because they are not like terms because of this. So I'm going to need to move the 20 over the other side by adding 20 to both sides. So then I'm going to get negative 7 equals 2.5 times VBF. And then I need to do negative 7 divided by 2.5. And I get a final velocity for B is equal to negative, and that's super important, 2.8 meters per second, assuming I did that right on my calculator. Seems about right. And that would be my final answer for number 2. Okay, go ahead and I want you to try number 3 here. Make sure you see the hint. That stuck together means they have the same final velocity, so you can use just one variable for the final velocity. Do number 3 and then come back to the video. Okay, so let's get this out of the way a little bit here. When we're reading, we should be annotating and drawing our diagram. So we have an initial velocity of 4 and mass of 2 kilograms for A. And then B has a mass of 5 kilograms and an initial velocity of negative 11 before the collision. And then afterwards, they're stuck together. So my before and after diagram is going to look like this. I'm just copying all the values. It's okay if we don't have everything, because the mass and the velocity together are going to give us the momentum. And then here, the key is we have one total final momentum of the two added together, and we have one velocity at the end. And then we're just going to follow the same procedure we've been following the whole time. We're going to write a general equation with all our masses and velocities, or our momentum. You may get stuck at some of these points with some of these problems if we give you masses and velocities for some and momentum for the other. You're going to have to substitute out mass times velocity and just put in one value for the momentum depending on what we give you. And then we just got to plug in our values here. So we have the mass of A and the velocity of A here. And we have, or B, I guess. Again, it doesn't matter as long as you're consistent. We have negative 11 meters per second and 0.5 kilograms. And then afterwards, we have VF and VF here. you could write this, if you wrote it this way, if you did the mass of one plus the mass of other times VF, that would be just fine. Because you're going to combine these two anyway, because now they are like terms, because they're both multiplied by VF. So we're combining all our numbers. These we can actually combine like terms. We're going to divide both sides by 2.5, and we get a final velocity for both of them, because they're stuck together, of negative 5.4 meters per second. So they're both moving to the left, and the green one over here was going faster. It caught up, it smacked into the other one, and they got stuck, and now they're moving together, still moving to the left, which makes sense. Okay, there you go. That is an overview of some of those practice problems. I think the big thing to remember is there's a ton of information here. You need to do step 1, which is annotate, and then step 2, or kind of maybe at the same time, draw your before and after diagrams, and then use the diagrams to plug in all your information into your equations. There you go.